It's 1975. The golden age of American V8 power was dying, and everyone knew it. Gas prices were climbing, emissions laws were tightening, insurance companies were punishing horsepower like it was a crime. Dealerships that once sold dreams of speed and freedom were now selling apologies. And inside General Motors, engineers were facing a brutal question. How do you keep the V8 alive when everything around it is trying to kill it? That's when Oldsmobile did something unexpected, something controversial, something that would get them mocked for decades. They built a V8 that was smaller, weaker, and on paper almost embarrassing. The 260 cubic inch small block. Most people look at it today and laugh. They call it underpowered, forgettable, a step backward, a mistake wearing a V8 badge. But what almost nobody knows is, this engine wasn't a failure. It was a survival strategy. And what happened next quietly changed the future of American engines. Because the Oldsmobile 260 wasn't just misunderstood, it was ahead of its time, and that's exactly why it deserves a second look. To understand the 260, you have to go back to when Oldsmobile was on top. In the late 1960s, Oldsmobile wasn't just another GM division, it was an engineering powerhouse, a brand that built some of the most respected engines in America. Their 400 and 455 cubic inch V8s were monsters. Big bore, long stroke, massive torque, the kind of engines that made the ground shake when you started them. The 455, for example, had a 4.126 inch bore and a 4.25 inch stroke. That's 455 cubic inches of cast iron muscle. In 1970, it made 365 horsepower and a brutal 500 lb-ft of torque. That kind of torque didn't just move cars. It twisted frames. It shredded tires at will. It turned ordinary sedans into weapons. People didn't just buy Oldsmobiles back then. They bought into a feeling, a rumble at idle, a surge of power at every green light. And for a while, it seemed like it would last forever. But by 1971, everything changed. Compression ratios dropped overnight, from 10.51 down to around 8.51. Why? Unleaded fuel and emissions rules. Power numbers collapsed. That same 455 dropped to around 250 net horsepower just a few years later. Some versions fell even lower. Engineers watched their creations get strangled by regulations. And then came 1973, the oil crisis. Suddenly, fuel economy mattered more than horsepower. Big block V8s became liabilities. Customers didn't want them. Regulators didn't want them. Insurance companies definitely didn't want them. And the government? The government was actively pushing for smaller, cleaner engines. Gas lines stretched for blocks. Prices doubled. And overnight, the American love affair with big displacement seemed to end. So GM had a problem, a serious one. They still needed V8 engines, but they couldn't be big, thirsty monsters anymore. They had to find a way to keep the V8 relevant, or watch it die. And that's where Oldsmobile made a bold move. Instead of shrinking a V6 up, they shrank a V8 down. It was risky, it was unconventional, and almost nobody understood what they were really trying to do. The result was the Oldsmobile 260 V8. Introduced in 1975, this engine was based on the familiar Oldsmobile small block architecture, but scaled down dramatically. It shared its basic design with the proven 350 cubic inch V8, but nearly everything was reduced. It had a 3.50 inch bore and a 3.385 inch stroke. That gave it a total displacement of 260 cubic inches, or about 4.3 liters. Compared to the 350 and 403 engines it sat next to, it looked tiny, almost fragile, and the numbers didn't impress anyone at first glance. Around 110 horsepower, about 205 lb-ft of torque. Those are four-cylinder numbers by today's standards. Back then, they were barely acceptable for a V8. So what was the point? Why build a V8 that barely made more power than some inline sixes? Why not just use a six-cylinder and save the weight? The answer is where things get interesting. You see, the 260 wasn't built to win drag races. It was built to survive a new world. It used a lightweight casting, thinner cylinder walls, and smaller internal components to reduce weight and friction. Engineers were chasing efficiency, not brute force. Every pound mattered. Every unnecessary ounce of rotating mass was cut. The bore size at 350 inches was relatively small, which meant less surface area for combustion heat loss and better fuel efficiency. The shorter 3.385-inch stroke reduced piston speed, improving durability at lower RPM ranges. It also meant less stress on the crankshaft and connecting rods. And then there was compression. Early versions ran around 8.0.1 to 8.5.1, low, yes, but necessary for emissions compliance and low-octane fuel. Higher compression would have meant detonation, engine knock, and failed smog tests. The camshaft was conservative, mild timing, smooth idle, nothing aggressive. This engine was designed to run clean, run smooth, and run reliably under restrictions that would have killed older designs. It prioritized longevity over excitement, compliance over chaos. But there was a problem. Actually, several problems. First, performance. Drivers who were used to the brutal torque of a 455 stepped into a car with a 260 and immediately felt the difference. It wasn't just slower, it felt weak, hesitant, like the engine was apologizing every time you pressed the gas pedal. 0 to 60 times stretched into the 14 to 16 second range. Quarter-mile runs were often in the high 18s, at around 75 to 80 in Pamhorg. That's not just slow, that's painfully slow. That's the kind of slow that makes you avoid highway on-ramps, and it got worse in heavier cars. Full-size Oldsmobiles with a 260 felt completely underpowered. Passing on the highway required planning and patience. You had to anticipate gaps in traffic. You had to build speed early. Spontaneous acceleration was simply not an option. Air conditioning made it even worse. Turn on the AC, and whatever remaining power you had seemed to vanish. So people started asking the obvious question: why even bother with a V8? Why carry the extra weight and complexity if the power wasn't there? And that question cut deep. It challenged everything the 260 was supposed to represent. But performance wasn't the only issue. The 260 also had limitations built into its design. The small bore size restricted valve diameter. That meant less airflow. Less airflow meant less power potential. The cylinder heads were designed for efficiency, not performance. They flowed well enough for a commuter engine, but they choked under any real demand. Even if you wanted to modify it, you hit a wall quickly. Go too aggressive with cam timing and the engine would lose what little low-end torque it had. Increase compression too much and you risked detonation on low-octane fuel. Swap in bigger carburetors and you'd overwhelm the heads. The whole system was balanced for economy, not power. The exhaust manifolds were restrictive. The intake was designed for smooth, low RPM operation. Everything about this engine was optimized for one thing: survival under emissions testing. This wasn't an engine you could easily turn into a monster. It wasn't meant to be, and that's where the misunderstanding really begins. Because while enthusiasts saw weakness, engineers saw something else entirely. They saw a blueprint. A smaller displacement V8 that could meet emissions standards, deliver acceptable fuel economy, and still provide the smoothness that American buyers expected. Remember, V6 engines at the time weren't exactly refined. Many were rough, unbalanced, and noisy. They vibrated at idle. They droned on the highway. They felt cheap. The 260, on the other hand, was smooth, quiet, familiar. It started easily. It idled without shaking the mirrors. It cruised at highway speeds without complaint. It felt like a V8, even if it didn't perform like one. And that mattered more than you might think. American buyers in the 1970s weren't ready to give up on the V8 entirely. They still wanted that smoothness, that refinement, that sense of quality. The 260 gave them that, without the guilt of terrible fuel economy. By the late 1970s, the 260 found its place in cars like the Oldsmobile Omega, Cutlass, and even some Buick and Pontiac models under GM's shared platform strategy. It wasn't glamorous, it wasn't fast, but it was there, doing its job. It became a transitional engine, a bridge between the muscle car era and the efficiency-focused future. Sales weren't spectacular, but they were steady. The engine appealed to buyers who wanted a V8 badge without the V8 fuel bills. People who drove in cities, people who commuted long distances, people who didn't need to prove anything at a stoplight. But then something interesting happened. GM started experimenting. In 1979, Oldsmobile introduced a variant of the 260 with electronic feedback carburation. This was early computer-controlled fuel management, primitive by today's standards but revolutionary at the time. A small computer received signals from an oxygen sensor in the exhaust. It then adjusted the carburetor's air-fuel mixture in real time. The goal was cleaner emissions and better efficiency. Sensors monitored air-fuel ratios. Adjustments were made automatically. The driver didn't have to do anything. It wasn't perfect. In fact, it was often unreliable. The sensors failed, the computers glitched. Mechanics hated working on them because the systems were so new and unfamiliar. But it was a glimpse of the future, a preview of fuel injection, of engine management systems, of computers controlling every aspect of combustion. And the 260 was one of the test beds. It carried that technology into the real world. It proved the concept, even if the execution was flawed. At the same time, GM was working on something even bigger: fuel injection, downsized engines, computer-controlled ignition systems, turbocharging. The entire industry was shifting, and the lessons learned from engines like the 260 were critical. Because here's the truth most people miss. You don't jump from a 455 big block straight to modern engines overnight. You evolve, you experiment, you fail, and then you improve. You build engines that seem underwhelming at the time because they teach you what works and what doesn't. And the 260 was part of that messy, uncomfortable evolution. It wasn't pretty, it wasn't exciting, but it was necessary. Still, its reputation never recovered. By the early 1980s, even GM started moving away from it. The rise of more efficient V6 engines, like the Buick 3.8-liter, made the 260 less relevant. These engines were lighter, simpler, and in many cases, just as powerful. They had fewer cylinders to feed, fewer parts to maintain, and they fit better in the downsized cars of the era. The 260 had served its purpose. It had bought time. It had kept the V8 alive long enough for new technologies to emerge. But now those technologies were here, and they didn't need the 260 anymore. Production of the 260 quietly ended around 1982. No big farewell, no legendary final run, no collector scrambling to buy the last one off the assembly line. It just disappeared. But here's where the story takes a turn, because decades later, when you look back at the 260, it doesn't look like a failure anymore. It looks like a stepping stone, a necessary compromise in one of the toughest periods in automotive history. Think about it, an engine with a small 3.50-inch bore, a modest 3.385-inch stroke, low compression, and limited airflow, still managed to deliver reliable performance under strict emissions rules, while maintaining the smoothness of a V8. That's not easy. That's engineering under pressure. That's solving a problem nobody wanted to deal with. And more importantly, it set the stage for what came next. Because the idea of smaller, more efficient engines didn't stop there. It evolved into high-output V6, then turbocharged 4 cylinders, then modern direct-injection V8s that make over 450 horsepower while still meeting emission standards and delivering respectable fuel economy. All of that traces back to moments like this, moments where engineers had to rethink everything, where they had to throw out the old playbook and write a new one. The 260 was part of that rewriting, a small, quiet part, but a part nonetheless. So why is the Oldsmobile 260 so misunderstood? Because people judge it by the wrong standard. They compare it to the monsters that came before it. The 455s, the 400s, the fire-breathing legends of the late 1960s, but that's like comparing a survival tool to a weapon. They're built for completely different purposes. The 260 wasn't built to dominate, it was built to adapt, to keep the V8 alive in a world that was trying to eliminate it, to give buyers a choice when there were no good choices, to prove that an American V8 could meet emission standards without disappearing entirely. And in that mission, it succeeded. In the end, the Oldsmobile 260 V8 didn't win races. It didn't break records. It didn't earn posters on garage walls. And it definitely didn't earn the respect of performance enthusiasts. But it did something just as important. It helped carry American engines through one of their darkest eras and into a new age of efficiency and innovation. It kept the faith. It held the line. A small engine with a quiet impact and a story most people never even notice. If you enjoyed this deep dive into one of GM's most overlooked engines, let me know in the comments what you want to see next. Another misunderstood motor, a legendary rivalry, or a forgotten piece of automotive history. And if you want more stories like this, make sure to subscribe.